Bloom applications is going to be presented by Bloom. Before we start, please see the links in the chat box to complete the sign-in sheet and brief quiz required by ASLA for continuing education. If you have any questions about the presentation, please enter these in the chat box and we'll have time for a Q&A at the end of the program. And now I'd like to introduce our presenters. First, we have Ron Alexander, president of R. Alexander Associates. Ron Alexander has over 35 years experience in composting and organic recycling, having worked with over 200 composting and organics recycling facilities nationally and internationally, including DC Water, and he's the creator of Bloom. He is a writer, trainer, and instructor certified with the Landscape Architecture Continuing Education System. And also I'd like to introduce the co-host, April Thompson, who is the Director of Sales and Marketing at Bloom. So at this point, I will turn it over to them. And again, at the end, we'll have time for question and answers.
Hey, thanks, Kevin. Kathleen, thank you also. First, let me clarify one thing. I am not the inventor of Bloom. If I was, I'd be traveling the world right now, probably, you know? No, that is an engineering marvel that I'll show you some pictures of soon. I have helped the organization quite a bit with product development. And I was mentioning to Kevin and Kathleen before we started, DC Water is a very, very interesting entity in that they're now creating this really, really interesting soil amending product. And they have the ability, they've basically been able to internally negotiate, and they have ongoing research funds where people like me get to go out in the field and figure out more things, better ways to use the material, what happens over time. And it's really a pleasure to be able to work with an entity like that. So welcome everybody. Again, yeah, you know, there's going to be a test. It's incredibly difficult test. So good luck with it. That's not true, but I grew up in Pennsylvania. I've worked on projects with the University of Maryland. I worked with Frank Guin, if you guys know that name, for many, many years. He was a mentor of mine. But I've been working with what I lovingly call brown products for a long, long time. I did crazy research back in ag school, learning how to turn certain organic waste into products. And I've worked on lots and lots of specifications, and it's a quite enjoyable thing. But if you have any technical questions as we go, let me know. Kind of my knowledge is technically based. But here's what we're going to talk about, a little bit of background and the trends in sustainable landscaping, the need, and of course, benefits and how to use these types of products. So, you know, starting off just as far as, you know, background goes, you know, Maryland, Eastern Shore. I mean, it's a really, really interesting part of the country. Every part of the country is a little bit different when it comes to climate and soil conditions. You know, your region has, and by the way, I actually ran a bulk materials marketing business in your region in my prior life in the 80s. But the soils in your neck of the woods are typically lower in organic matter. Obviously, the closer you get to the water, you have coarser textured soils. Farther away, and most of you probably have to deal with these denser silt clay soils that can be quite dense. Rainfall is moderate, snowfall is moderate. We get good winters in the region, doesn't get, incredibly cold. However, it is important to know that the state does have low-lying areas, and because of that, the impact of climate change is probably going to be a little bit more dramatic. It is also important to know that when we have low-lying areas and you have some dense soils, that actually causes additional stresses to the system. Climate change is something that's affecting us more and more, and I'm a big believer, having studied soil science and plant science, that landscape and soil management programs, we know can help ameliorate the effects of climate change, really the least expensive way to do it. And I think we have to look more and more intensively at using landscapes, designing landscapes to better help with climate change. I often use the term dual purpose landscapes, ones that look really good and function. And I think that's the way forward in many, many cases. That trend is going on in our industry. As we all know, there are different programs. um, we're starting to adjust to change. We're also trying to build landscapes that kind of exist in nature a little bit easier. So these green trends continue to grow. You'll often hear the term sustainable landscaping. There's a bunch of different definitions here, not to read it, but they're slightly different, but they all reference basically landscapes that kind of work a little bit better with nature and positively affect the environment, have environmental benefits. So again, we're talking about building really pretty landscapes, but also landscapes that function and provide what I like to call environmental resiliency. Build, improve the soil to allow the plant to to persevere through difficult times, climatic change and other things. And sustainable landscaping in many ways is hinged on improving soil health. And there's a wonderful movement going on across the country to improve soil health. And really, soil health is just a synonym for soil quality or improved soil functionality. And what we're really talking about when we go to plant things and we consider the soil, we consider the chemical, physical, and biologic properties. We don't just look at throwing nutrients on the ground. We understand that it's more complicated like that, and we plan for it. Um, Basically, all the industries that help manage land and use plants are affected by these changes in sustainability, and also are impacted and embracing soil health. Now, for our part of the world, when we're talking about land management, there are key factors on why it's so important to us. Soil losses is a very big issue. Erosion control. When we lose soil, we lose organic matter. So it's a double whammy. Hurts us to growing plants as well as hurts the environment. Of course, stormwater management, water conservation, um, really enhancing um, animal and human habitat also. But some of the key things that impact us, people who design landscapes and have to deal with clients who pay for it, is that if we deal with soil health upfront, there's a much lower chance of plant loss through establishment, um, and ongoing. And of course, over a longer period of time, site maintenance costs go down. So we can reduce cost on an ongoing basis by thinking things through early on. Remember, or I should say that we try to address these concepts through really smart programs and initiatives like the Sustainable Sites Initiative that you all know about. Um, there are state-based programs that are embracing soil health. They're typically based on managing stormwater or helping to reduce irrigation usage. Washington State has a quite incredible program called the Soils for Salmon program. That's based on stormwater management. The city of Arlington that's an ordinance, that's law. Um, Arlington has a program that is voluntary, but it's also about creating smart landscapes, the River Smart program to protect the rivers as well as create smart through creating smart landscapes. So if you don't know about that, that's an interesting one to look into. And of course, these soil health programs are also programs in certain states that are being developed to improve water conservation, You'll sometimes see this water sense icon. And this all one of the key aspects here when it comes to using less water is smart irrigation, but also modification and improving the soil. So these healthy soils do all these wonderful things. Their functionality is improved, and it helps both landscape and agricultural soils. And of course, organic matter is the key. We can never forget that we're not going to stop building. You know, we can only hope that we'll build smarter over time, but it is important to know that, you know, we have less green space in some of these cities. We have more compacted area, we have more concrete, and for this reason, without grass, without landscapes, it's a really it's getting harder and harder to manage stormwater and having water infiltrate and recharge aquifers. So one of the things that we don't talk enough about when it comes to climate change is there's really going to be real costs involved, which increase costs with managing stormwater as we move forward. And what we found out is through smart landscaping programs, it's one of the least expensive ways to deal with that. But why else? Why else do we need to fix soils? Well, I think we all know that there are certain sites we're typically dealing with. The soils that we have on the sites that we landscape are not typically true topsoils. They're topsoils, they're typically removed or mismanaged, but you know, we may have a coarse base material that's kind of sandy and drouthy. Typically, sandy soils, of course, do not have the ability to hold on to nutrients. They have a low cation exchange capacity and they're prone to wind erosion. So organic matter can help slow down water movement, add cation exchange, bind the soils. But most of the soils in the region are going to be dense. They're going to be finely textured, silts and clays. The biggest problem we're going to have on our sites is going to be compaction over time. So poor drainage, poor water percolation. Remember, the denser the soil, the denser the soil is, the more energy it takes for a plant to push its roots into the soil. So one of the things that's so beneficial to soil amending is we add organic matter, we create large pore spaces that are much easier for roots to shoot their roots through, and roots will always follow the path of least resistance. Also, of course, adding organic matter to fine soils helps soils aggregate and clump together, which helps create these pores that are stable, water stable. What else happens though? A lot of project sites we deal with, you know, the top layer, the A horizon are removed. You know, they remove soil so they have soil that can be compacted that you can build on, right? But we don't always get that soil back. Sometimes we have decent soil and there is some big old heavy equipment that rides over it that basically pushes the air pore space and compacts the soil. And there are places where you can plant sod and literally have a difficulty getting the plant roots to actually go down into the soil just from the excess compaction. So it's important before we start the project is to understand your soil. The easiest thing to do on a project is soil test ahead of time. It takes a little extra planning, but it's really important because we can't properly plan for the right plants unless we know the characteristics of the soil. We're typically looking at the physical, chemical, and biological properties of soil. And it is really important that most of soil's characteristics are impacted by organic matter content. So, I mean, that's a key aspect. We don't always talk about that, but organic matter is really key to improving soil quality. I always encourage landscape designers, landscape architects to find a lab they feel comfortable with, a soils lab that if they contact them or they get test data from them, that they're willing to spend time on the phone and answer questions. It's really, really key. So, getting down to soil basics just quickly, we always have to remember the basics of soil. It's supposed to be the top surface of the soil, fine, but it consists of a mineral fraction, sand, silt, and clay, which are categorized by size, organic matter content in different ages, by the way, plant nutrients, water, and living creatures. So, soil texture, I apologize. It seems like everybody's trying to call me. Soil texture is a key aspect of evaluating soil. It's basically, if you've not seen the soil texture triangle, it's a grid system. We test the soil for the volume of sand, silt, and clay, actually the amount by dry weight. And it tells us where we fall on this triangle. And based on where we fall, we have a better understanding of what the characteristics of the soil are and how best to manage it. So I just wanted to show you, though, the pictures off to the right. Off to the right, you see a picture there of sand, which is magnified 45 times. And you can see it's somewhat rounded in nature. And you can understand how there's a lot of pore spaces there. Water goes right through that, perks right through it. On the bottom are actually clay particles. They look like sheets of paper lying on top of each other. And if you look at them, you can understand how they can get quite compacted and dense. And the interesting thing about clay is the pore spacing is so small that it's tough to get wet. But once it gets wet, it's tough to get dry again. And we all know this, right? But it has to do with this pore sizing. And if we improve soil, we help it function and aid the plant, to be a good, hospitable medium for plant growth, to be a repository for both plant nutrients and water, and provide a medium for plant life or microbial life. And it is important to say again that, these microbial populations in the soil are important. They live in symbiosis, a lot of them, with plant roots, and many times growing on the plant roots and working as extensions of plant roots, helping them absorb water and nutrients. Now, on top of that, a healthy soil is good at binding and degrading pollutants, at absorbing runoff, and sequestering carbon. So by reestablishing the carbon cycle in our landscapes, not only do we help the soil function for the plants, but for the environment. And that by adding this carbon to the system, we basically fuel the soil food web. A very, very diverse types of creatures living in the soil, again, along with plants. Now, back in the old days, we used to look at this picture and say, this is the perfect soil. And soil is 50% solid, 5% of it is organic matter, and half of it is pore space and water. And yeah, that's great if it was real. We very rarely have a soil that is this perfect. This is really the goal. I used to remember talking to Frank Guin, and obviously he used to preach soils testing in landscaping, but he would always say, you have to assume, even before the soil testing is done, that there is soil amending that will need to be done, because that basically is just typically the case. We're not getting the best soils. It is important to understand there's different types of soils. There are living soils. There are living organic matter. Different types of soil organic matter. There's living biomass like microbes and bugs and roots. They die off. They become the active fraction of organic matter, and microbes aggressively break that down, try to break that down, and by doing it, cause certain benefits to the soil. And then as as that organic matter becomes more stabilized, becomes passive, more passive organic matter, and it provides benefits, but different types of benefits like water holding capacity, things like that. Okay, so the concept here is by fueling the system with organic matter, the organic matter ages over time. There's a broad array of benefits that the plants and the soil gets by the organic matter being in there. And by improving the soil, we actually create more biomass through the growth and death of greater populations of living creatures in the soil. So that's the goal. We're trying to create a system that once we fix it, we perpetuate it. And the best way to perpetuate it is to obviously is with vegetative cover or a mulch cover, um, which can help shade the soil and add organic matter to it over time. Remember that most good organic matter sources, including Bloom, they have a fraction of incredibly stable organic matter that's called humus or humic substances, and we can measure for that now. And this 3% in Bloom is actually quite a high number. But you can buy bags of humic substances now, or you can use um, um, carbon-rich soil amendments. And it's, of course, it's also important to know as we add carbon into the system, um, there are a lot of other things that happen. And remember that a lot of the carbon that gets when we add carbon to the soil, we add it to the soil to improve the soil and help the plant roots, but also fuel the microbial population. The trees, the plants actually get carbon to build roots and leaves and stems, of course, through photosynthesis, through the carbon cycle, through CO2. So adding organic matter to the soil creates a lot of benefits, physical, chemical, biological, and environmental. Again, throughout Maryland, one of the probably the greatest benefit is an improvement to soil structure. And improving, creating pore spaces, reducing bulk density, holding on to more water, better pore spacing, uh, which provide just lots and lots of benefits, including reduction of soil compaction, which is a big deal. There's been lots of research. The research on the bottom, if you see these plants at the bottom here, this is research that was done in Maryland back in the early 80s, where we incorporated organic matter into soil to see how much faster and larger the root systems we can grow for trees and shrubs. And of course, we know that works. By adding organic matter to the soil, we create a larger reservoir we increase the field capacity of soil. We sometimes talk about trying to get to 5% organic matter in the soil. And if we can get to 5% organic matter over an acre of soil, a foot deep, we can hold 75,000 to 100,000 extra gallons of water, which is a big deal. But also we can not only hold more water, but by improving the pore space, we're much better at absorbing stormwater, which is a huge deal because that's how we have erosion problems. Here's some research I was involved with a few years ago, adding Bloom to the soil. Here's a clay soil, 100% soil, 10% Bloom, 20% Bloom. Here's sand, 10% Bloom, 20% Bloom. And you see as you start adding it, not only do you increase water holding capacity, you can see that increasing here on both types of soils, but you also see the hydraulic conductivity, basically infiltration rate, improving. And back in the old days, back in the 80s, I remember we would see this type of thing when we fixed soils with organic matter, and we would see both an improvement in water holding capacity and water movement. And people would be befuddled by that, thinking that you should add sand to the soil, to these heavy soils, to help percolation. And that is, research has shown that is not the thing to do unless you have a bunch of money and you buy a lot of sand. Okay. The Bloom Woody Blend, which is a product that you would kind of use in the same application rates as you would compost, 20 to 30% inclusion rate into the soil. You see the same benefits here for sandy soils and a silt clay soil. That the more we add, the better the water holding capacity and the better the infiltration or the perk rate. The addition of these materials, of course, also adds lots and lots of negative charges. Plant nutrients are positively charged primarily, most of them, all of them primarily, except for nitrogen. But the bottom line is we add organic matter to soils, even to clay soils, and we we enhance the ability of the soils to hold nutrients. That's a benefit long term, that we lose less through water movement and we hold more in the plant root zone. So hopefully we fertilize less. We actually, not only do we provide carbon to feed the soil biology, but we also bring in soil biology, which is very, very important here, including certain microbes that have shown a tendency to be disease suppressive, to help with natural disease suppression. And of course, by fixing the soil with organic matter, the plants grow better, there's more photosynthesis, and we're able to sequester more carbon from the air. And we shouldn't forget that plant roots also exude some pretty good carbon out of their root system, which also helps keep organic matter into the soil. So, that leads us to this new tool that's available to the marketplace. Really, in Maryland, there are different types of organically based, carbon-based soil amendments. But DC Water is creating a product from biosolids that are treated through a thermal hydrolysis system. It's a high temperature, a high pressure system, which means everything that comes out of it, it's pathogen treated, but basically it kills all weed seeds. The technology is quite brilliant. It was created overseas. DC's facility is the first one in the country. It's the biggest one in the world, and actually is generating something like 30 or 40% of the energy they need to operate their wastewater system there. So it's a really cool program, to all the benefits it's bringing to the region as far as cutting emissions and saving money and energy. But it's creating this really, really consistent, high quality product with some really, really unique benefits. We talked about the benefits of adding organic matter. The product is pretty nutrient packed. Most of the nutrients are in a very, very slow release form. One of the unique things about the products, a couple things, is that we've measured it for humic substances. It's quite rich in humic substances. But also there's been interesting work done through Virginia Tech, showing that the material has disease resistance capabilities that are not related to organic matter. Has to do with plant growth hormones and such. So it's a very, very interesting and unique material. There's been a lot of success using it in the field. Their base product is what they call fresh bloom. It's a wetter material that's used on large land products and in agriculture, and a lot of soil blenders are using the product. We've had really great success with large urban landscape and soil manufacturing projects with this type of material. Urban Zinc has used it in a couple of very, very large projects, including to build ball fields and school turf areas. Typically, an application rate is about 1 inch incorporated into 6 inches. You will be provided with a substantial amount of nutrition that will meter out over about a 3-year period. So you'll cut back fertility pretty aggressively the first couple of years. This data is not to study. It's a research that I'm just getting completed with, that's been funded by DC Water. But we basically mocked soil manufacturing trials out in the field, and we wanted to track the changes in the soil as the soils stabilize over time. And one of the things we noticed is that bloom has a pH over 8, and that freaks some people out. But we know that that number is very transient and is there because of ammonia. And what we were able to show in this research is that you put this material in the soil, and the ammonia is used by the plant, or it basically it gets converted by the microbes to nitrate nitrogen, or it binds with clay particles. And then when it drops, salt content drops, the soil pH drops to basically right around the background level. So what we've been trying to do through this research is show what happens, so we can explain to people what happens over time when you use the material, because it's a newer product and they have more questions. Here's another big land project that was done, Route 5, soil manufacturing. And in this case, we use soil from the site, 60% soil, 30% sand, 10% bloom, and manufactured soil on site that met the Maryland State Highway Association's approved soil specifications. So it's a very, very interesting product. For projects like these large land projects, it would be much less expensive than compost would be. Here's another a part of that project site right there. You can get this type of product that's been aged and dried down a little bit more in bags. April can tell you more about that if you have interest. The material does have a guaranteed analysis, so it's technically labeled as a fertilizer, but it's really a soil amendment with nutrient capacity. It's been used in a lot of tree planting and general landscaping projects, including those with KC Trees, which does a lot of work in DC tree planting. One of the things at their facility that is quite unique is they have a soil blending program right there on site, and they've been able to create some soil blends, or I should say, really, their soil amendments that have particular applications. There's a bloom woody blend, which is really it's bloom and a bark material that's blended and aged a little bit. The material is quite rich in organic matter, and you basically use that the same way you would a compost. We've had really, really good success with this material. Excuse me. We've used it on golf courses, even on fine turf. We've used it in landscape gardens and nursery beds, even to establish some wetland meadows. And they also have another product which is a little bit unique. It's a combination of actually the bloom, bark again, and sand. And that material has been used like in Mount Vernon for a plant nursery, but it typically is used in lawn top dressing types of projects. But that material is just about something that you could plant into itself. And here's a before and after. Obviously in a project like this, we would core aerate to pull plugs out of the soil, top dress with a 1/4 to a 1/2 inch, back drag it real well, seed, and go. We'd be done. So, using that type of product, you'd apply a 1/4 to a 1/2 inch over turf. If you're going to use bloom or the woody blend, you would typically be incorporating that into the soil. You would use higher application rates. Bloom, you typically use a 1-inch application rate into 6 inches, and the woody blend 1 to 2 inches, depending on what your desires are there. And the one thing the organization they've done a really, really good job with is creating end use tools. They have a lot of information on the product. They also have university data if people are interested in learning more about the work that's been done with the product. And they're always available to answer questions. So I hope you enjoy the time talking a little bit about soil improvement and its importance to landscape sustainability. I think it is important for us to know that especially in this day and age where we have a lot more stress on landscapes, we kind of have to understand that all of our projects are going to need some soil improvement. Soil health is really, really key to successful sustainability of landscapes, long-term sustainability. And these use of these organic recycled products is a great tool. And it's also important to know that, as we start talking to our clients and say, let's do this right. It is important to know that by creating these healthy soils, we are going to have impact on the environment as well as the long-term beauty of a site. So, and just finishing up, I just want to mention that we've been developing end use specifications. So if there are landscape designers or architects who want to try to put these types of products into their specifications, we can work with them and providing the text necessarily to do that. There's also other technical literature. If you're interested in some type of lunch and learn with a particular landscape architecture firm, that's possible, and also a provision of technical assistance. So thank you again for listening. I really appreciate it, and I'd be happy to answer any questions if I can. Thank you very much.
Thank you, Ron, for that presentation. I think at this point, April is going to help moderate some questions and answers. And I believe I need to help her unmute real quick.
There we go.
There we go. All right. April, I'll let you take it from here.
Great.
And everyone else, please just make sure to add your questions into the chat, and we'll try to get to as many as we can.
All right. So I have a question from Chris Shipley, which is, do you get diminished returns with organic matter over 5%?
Yeah, I think you kind of do. I think most of the research we've seen with these soil amendment products, they start to cap out at a 20 to 30% inclusion rate. And it kind of depends on where you are and what your environment is. If you're building a wetland, you actually may be building a soil that has 10% organic matter, but that's not typical at all. So yeah, I think that there is a level of diminishing return. And I think you guys, landscape designers, are in a difficult position because you have to spec enough, knowing that sometimes the people who that do construction may cheat a little bit and not put down the full amount, but you don't want to add so much that you raise the cost of the project so much.
So far, we don't have other questions, but since I have you here, maybe you can, oh, here we do have another. From Larry Quorick, who wants to know, for larger amounts you purchase directly from DC Water, the average price for bloom, is it sold by the cubic yard? Yes and yes. So DC Water has created this sort of separate but freestanding but connected entity called Blue Drop. So that's my direct employer, and we do all the sales and marketing of Bloom for DC Water. So you would reach out to me essentially, and we can, basically deliver for, as small as a yard within a limited range, or as much as, however many truckloads you might need for a project. In terms of the price per yard, so we've got a number of different products, as Ron mentioned. The blends that we do, they start at, well, they go as low as $10 a yard if you're ordering, say 100 yards or more. Otherwise, for small quantities, it's 20 to 24 a yard plus delivery. And then you know, we also have on our website all of the resellers, and they're going to price it, you know, according to, you know, to their market. So that that depends. And let me just type in the chat here my email address. So if people do want to get a quote for anything afterwards, welcome to. Oops,
There was a question here. Oh, there was a question about what is bloom. I think that was answered, but you know, basically it's processed Class A biosolids. That's basically weed free and turned into a form where you can use it as a soil amendment.
Yeah, and since some folks, you know, may be familiar with Orgro, since there's a lot of folks around Baltimore, maybe you could talk about like bloom versus Orgro, if people are familiar with that.
Yeah, sure. Well, you know, it's interesting because the standard for many years, composting, you know, started heavily in the 80s and really went crazy in the 90s and keeps expanding, and it makes a wonderful a product. It takes, you know, on the short side 4 months to 6 or 7 or 8 months to make a good compost product. It's very rich in organic matter. It's more stabilized than bloom is when you first buy it, not the blends, but the fresh material. And it's typically more expensive, but they have similar amounts of organic matter. The bloom would have more nutrients, but the bloom woody blend, the bark product, was created as a comparative product to compost, to use it at the same application rates. The fresh bloom would be a more concentrated product, and you use it at lower application rates. But basically, in theory, you could take a product like bloom and add wood chips up into it and pile it up and get it to compost. And DC many years ago did that, but they are now using a newer technology, and they're making a product that's faster.
Right, we're sort of accelerating over the composting process, so it's not necessary. I know Chris likes to sort of refer to it as accelerated nature. Kevin asked what the difference between bloom and regular compost is. I think you kind of answered that, but I think it's worth elaborating a little bit because so many people are used to speccing in leaf grow. And when we talk about compost too, it's like a food waste compost versus a leaf compost isn't going to have the same nutrient or even, you know, pH necessarily.
Right. And, you know, so there's, you know, in the Baltimore area, obviously there are biosolids compost. Some of them can be quite high in ammonia, so you have to be careful that you properly incorporate them into the soil. So you don't have any damage. There's lots and lots of materials like leaf grow, which is a pretty high quality product. Both of those materials have pretty good organic matter contents. The leaf compost, the leaf and food compost are typically going to have less nutrients than are the biosolids compost or the bloom wood. And all of these products are typically pretty rich in nitrogen and phosphorus and pretty low in potassium. Okay. And both the nitrogen and the phosphorus are available at very slow application rates. The interesting thing about the biosolids products, whether it's bloom or compost, is they also have a lot of iron, and iron and nitrogen impact color, chlorophyll. So these products, very often you'll see the grass or leaves turn a very deep green. That's quite attractive to some people because it creates an illusion of flowers being brighter. So that's one of the benefits of using the biosolids type products. And then food waste is on the rise. You know, more and more food waste. I just saw that they're waiting for a bill to be signed in Maryland about food waste recycling. The only bad thing about food waste recycling, I do a lot of work in California, is sadly we're getting physical contamination being brought into the products because of packaging, and composters have to work that much harder to make a very, very clean product. But hopefully we'll be able to deal with that over time.
Yeah, we have all sorts of different customers, but we have some kind of fancy public gardens in the area, like Tudor Place, which was Martha Washington's descendants, carried it on until eventually went private then public. And they ended up turning to Bloom because they were getting plastic in with their usual compost, and also the introduction of weed seeds, of weeds that they didn't already have. Which, because of Bloom's processing, I mean, it goes through, it's like a giant pressure cooker that, no weeds could survive. So I do think that is a distinction with our material. Julie Higgins had a question. If you could determine, how can you determine if compost has the proper balance of living, active, and passive components?
Yeah, that's not an easy thing to figure out. One of the things we have found out with compost products is young compost products are not great, and old compost products are not great. Now, when I say not great, that a quote unquote properly aged material typically has the greatest breadth of types of microbes in it and have the greatest disease suppressive characteristics. Young products don't, and old products, some of the food necessary for the disease suppressive microbes is gone. So it's really, really a hard thing. And frankly, microbial testing is expensive. There is testing that can be done. We can test these products for microbial functional groups, but we don't get down to species. But there's data to be learned there. But I think what we've kind of learned over the years is that with a lot of these products, we're bringing in organic matter. The organic matter is seeded with soil microbes, and when we bring it into the system, they flourish because it's food that's readily available for them. So I hope that answers the question.
Yeah, and this dovetails slightly, I guess, with Larry Quark's question. If there's a shelf life, e.g. recommended time to place Bloom within the soil once it's purchased and delivered.
I don't think that there's a particular shelf life, but I will tell you, if you get fresh Bloom, no, I mean, I think your goal is going to want to be, I think with, one of the things we find about soil amendments is they're pretty stable. The farther you go south, the faster they degrade when they're out of the soil and even in the soil. But in the mid-Atlantic area, I mean, I just think it's important to get it in the ground because you could lose some nitrogen in the form of ammonia. And if you get that material into the ground right away, the nutrients fix onto the soil particles, and you basically conserve nutrition. And I think that that's a beneficial thing.
Let's see. Brenda had a question. Is DC doing this product type to help resolve their combined SWM and sewer system issues? The decision to put in this Canby system is really, multifold. It is helping to greatly reduce the actual amount of material that is coming off the belts. We have 450 tons of material every day, which sounds like a lot. That's actually a significant reduction, which in turn means reduced costs, reduced carbon footprints, and a product that is just superior, both in terms of its odor and you know, its usability, its workability. And then the process, as Ron mentioned, also, you know, generating electricity to, you know, fuel the plant. So it's just like overall a win-win. You know, it's a very expensive system to put in, but the payback period, you know, I think relatively short considering all of the benefits, and then the fact that we're able to, you know, recoup some of the costs through the sales of Bloom at an affordable price. I think, you know, that you know, we've really in the last couple of years built the market up for this, and you know, so obviously it's benefiting the farmers and landscapers and others that are using it as well for their gardens and landscaping.
It is important to mention really quick that this process that they put in basically helps the creation of methane, greater volumes of methane, which are captured through the process. And that's how they're creating electricity energy, is through the generation and the capture of methane. And they're actually going to be starting a program where they're even going to be putting in solar panels going into the future with the goal of getting as close to carbon neutral as possible. I don't know how long that's going to take. So the organization is pretty forward minded when it comes to that kind of stuff.
Yeah, it's cool because we're talking to other municipalities in Mumbai, India, in Lima, Peru, you know, other parts of the world and country that are really interested in doing what we're doing, because there are still municipalities that landfill the material, which, you know, on a few levels is just kind of crazy. So, you know, when people are purchasing material too, they're kind of, you know, they're helping be a part of this closed loop system. So let's see, what else do we have here? Would you recommend adding a thin layer of bloom annually to native planting beds during dormant seasons?
Native planting beds, I would not. I would prefer, if you're trying to build up organic matter where native plants are being grown, if you're talking about like true native plants, I would rather you use the woody blend, the bark blend product. I think that would be a more functional product. A lot of natives they like organic matter. People think they don't, but they don't like a lot of extra nitrogen. So I would prefer using something. I would use the woody blend. I think that'd be a much more functional product.
Yep, I think that should do it. I think Kevin is going to close it out with some announcements. Thank you, everybody, for
thanks for the questions.
Yeah. Kevin, over to you. Oh.
Sorry, we got our unmuting working here. Well, thank you guys again so much for this presentation, and thank you everyone who has joined us today. We will, as I had mentioned earlier, have these on a monthly basis. We are finalizing our presenter right now for May, but keep your eyes on the newsletter that we will send out the beginning of May, because hopefully we'll have in there who that will be and the exact timing of that. And also just an announcement, we do have a lot of different activities going on and committees that are open right now. So if you're looking to get more involved with Maryland ASLA, please feel free to reach out either to me directly, or you can contact us through our website. But we're always looking for more people to get involved so we can continue to do programs like this. So thank you guys again for taking the time today, and we hope you have a wonderful weekend.